We are now going to take a look at example 3 from chapter 6.1. This can be found on page 300 of your textbook. It is solving a real-world problem by graphing a linear inequality with discrete whole number solutions. So that idea of a real-world problem kind of makes it nice because we can see a context to using this stuff. The question reads, a sports store has a net revenue of $100 on every pair of downhill skis sold and $120 on every snowboard sold. The manager's goal is to have a net revenue of more than $600 a day from the sales of these two items. What combinations of ski and snowboard sales will meet or exceed this daily sales goal? Choose two combinations that make sense and explain your choices. First thing we're going to do here is label our variables. Now we've got skis, we have snowboards, so rather than using S for one and something else for the other, we're just going to say that skis are X, snowboards, you can probably guess, are going to be Y. That's the first thing we do is we label our variables. The next thing is determine if there are restrictions. Now since we're talking about skis and snowboards, it probably doesn't make sense to have fractions or decimals, and it probably doesn't make sense to have negative numbers. Neither can we have any real number, nor can we have integers. So we are simply going to have whole numbers. So our restrictions are this has to be an element of the whole number system, and Y has to be an element of the whole number system. This is going to dictate what kind of shading we're going to do later on. Next thing we're going to do is come up with the equation. Since they make $100 per pair of skis, we can say it's 100x and $120 per snowboard, 120y. Now this manager wants to make more than $600 a day. It doesn't say at least. It says more than 600, so the inequality is going to be greater than pair of skis plus the amount of money made from all the snowboards has got to be greater than $600. Now we're going to graph this so we can figure out some solutions that are going to help us solve this problem. Now to graph this, there's several different ways we can do this. Got a zero there. There's several different ways that we can do this. We can determine our x and y intercepts. That'd be a fine way to do it. Another way that we can do this is by isolating y and using the slope and the y-intercept to graph it. So just for something different, why don't we go ahead and do this? So first thing we'll do is change it to an equation so that we can found our boundary. We're going to isolate y here, so we would subtract 100x from both sides. Cross those out. It'll be 120y equals negative 100x plus 600. In order to isolate y, the next thing we will need to do is divide by 120 everywhere. Cancels these out. When we reduce our fractions over here on the right-hand side, we'll be left with y equals negative 5 over 6x plus 5. Now we did not divide by a negative number here. We divided by positive 120. So our inequality symbol is going to remain as greater than. So we can rewrite our inequality as y is greater than negative 5 over 6x plus 5. From this equation right here, we can all see that the slope is negative 5 over 6 and the y-intercept is 5. We can use that information to graph this. Now, all that, we're dealing with whole numbers only, and there is no possibility for equality. So what that's going to mean is we're going to need to have, as you can see on page 302, we're going to need to have a dashed orange line with orange shading on the appropriate side, as well as stippled green on the whole numbers. So let's go ahead and try and graph it. So the y-intercept was 5. Again, remember that my red marker is going to be used as, imagine that it's orange. So we're going to start the y-intercept of 5. The slope was -5/6. So that's pretty easy for this one. We can go down 5 units to 0 and over 6 units to 6. And so that's going to be the next point. So we are going to connect these again with a dashed orange line. So that's our boundary line. Beautiful, straight. Next thing we're going to have to do is determine which side of the line gets shaded. So what we can do for that is go back to our original inequality, which was 100x plus 120y has to be greater than 600. We can substitute the value of the origin, 0, 0, to determine if we get a true statement. So 100 times 0 plus 120 times 0 should be greater than 600. I think you can see where this is going. 0 plus 0 should be greater than 600. 0 is greater than 600 is what it leaves us. Not a true statement. So since that's not a true statement, the point 0, 0 is not in our solution region. So instead of shading below this line, we're going to be shading above this line. So here's my orange shading. So what I'm going to have to do next is grab the green marker and do some green stippling. So keep in mind this has got to be whole numbers only because we're talking about skis and snowboards. So we're going to put our green stippling on the whole value. So here's a point 6 and 1. Here's a point 6 and 2. Here's 5 and 2. Here's 4 and 3. 4 and 4. So all these values are going to work. So anywhere where I put a green dot, this is a value that should make our inequality true. It should be a solution. On page 301, 300 and 301, what you can see is what they did when they did this in the book was they used the graphing calculator to come up with the line. That's fine, you can do that too. But we just, for fun, I guess, we just did it out this way. So now the question asks, we go back to the question, says choose two combinations that make sense and explain your choices. So we're going to choose two values from our solution region that are going to make sense. So let's say we go ahead and we pick this point right here, 4 and 4. 4 pairs of skis and 4 snowboards. So the next thing we're going to do is test it to make sure that that works. So we have our inequality of 100x plus 120y has got to be greater than 600. So we're going to test that point 44 to ensure that it's correct. It seems like it should be. We're going to check to make sure. So 100 times 4 plus 120 times 4 as well should be greater than 600. We've got 400 plus 480 should be greater than 600. We get 880 is greater than 600. True statement, meaning 4 pairs of skis and 4 snowboards is going to be a solution such that this snowboard shop and ski shop would make $600, at least $600 a day in revenue. We could choose another point. For instance, we could choose the point 5 and 3 right here. It should be a point, same idea. We should test it. So 100x plus 120y should be greater than 600. We'll put in 5 for skis, so 5 for x, and 3 for snowboards. Again, this should be greater than 600. Here we have 500 plus 360 should be greater than 600. We get 860 greater than 600. Again, a true statement. So clearly 5 pairs of skis and 3 snowboards is a possible solution such that they would generate at least $600 in revenue per day. It says, would raising the daily sales goal to at least $1,000 change the graph that models the situation? I think it clearly would. State 2 combinations of ski and snowboard sales that would meet or exceed this new daily goal. So let's hear what this person has to tell us.
Change the graph that follows the situation. I substitute 1,600 in the inequality that Jerry used. Then I simplified and isolated y. The new daily sales goal does change the graph. The equations of both boundary lines have the same slope, but the y-intercepts are different. The y-intercept of the boundary line of the new inequality is higher, 8 1/3 greater than 5. would result in sales of $1,100. This combination would exceed the daily sales goal. I substituted 4 6, representing 4 pairs of skis and 6 snowboards, into the new inequality. Since selling 4 pairs of skis and 6 snowboards would result in sales of $1,120, this combination would also exceed the daily sales goal. Sales of 5 pairs of skis and 5 snowboards, or 4 pairs of skis and 6 snowboards, would exceed the daily sales goal of $1,000.
So what we can see is that when we added 600 to 1,000, everything was the same, except the y-intercept was different. Keep our graph essentially the same and move it up. Any questions about example 3 or chapter 6.1, please bring them to class tomorrow. Thank you.